Hello students, this is Professor Urvish Mewada, Head of Electrical Department, Sri Swaminarayan Institute of Technology, Bhat, Gandhinagar. I am the subject matter of Interconnected Power System, which is in the 7th semester GTU, and the subject code of this subject is 2170901. Students, in before two lectures we studied about the basics of interconnected power systems, advantages of interconnected power systems, as well as the disadvantages of the interconnected power system, and the types of interconnected power systems. Now this is the third lecture, and for third lecture the for the chapter number 1, interconnected power system, the topic is cascade tripping, uh, or blackout. Now this cascade tripping is associated with power outage of particular area. So generally cascade tripping is related with blackout or power outage. So it is also say the loss of electricity or electrical supply. So this happens just because of the means suppose here I am giving you one example. If the load is connected with the system, and that load is light load, and if we increase that load further to the means peak load of that particular power system, so due to that stresses will develop in the system if that load remains continuous for particular time. And if that load further increase beyond the limit of that system, then that will transfer that means load, or we can say stresses, to the nearby station. And due to that a part of the power system, or the whole power system will become uh, uh, will become will comes under to the stress, and due to that cascade tripping will develop. So cascade tripping is the, we can say, failure of a power system of interconnected parts, in which the failure of the parts can trigger the failure of successive parts. Means that's suppose the stresses which develop due to the load, the power system or the unit is not capable to withstand that much amount of stresses. Then that stresses will transfer by that power station to the nearby station. And if it is again, and then next nearby station is not able to withstand that stresses which transferred by the main unit, then again that will be transferred to the other station. And certainly the stresses will adding and increased from the initial level to the successive parts of the transmission system, uh, generating and distributing system. So due to that the power cut or power failure and power loss and blackout will occur. So these are the reason of cascade tripping and blackout. So again we can say that as I explained you, when the one element is fails and shift its load to the nearby element, means as I explained you that element or a unit, if that a unit is fails to withstand the stresses of the load, and that's why that element transfer that load or stresses to the nearby station. And those nearby stations elements are then pushed beyond their capacity. Means the load which is it is, if it is already loaded by uh, their area of the load, means of the consumers, and if the further load comes from the faulty parts, then the load which is connected to that element will increase, and so that the stresses on that element will also increase. And again they shift their load to other elements, then this is setting of more overloads, and thereby taking down the entire system in very short time, and that is called the cascade tripping. And These are the causes of cascade tripping. As I explained you, components of grids are overstressed. This overstressed word is associated with the load. If the load of the line will increase beyond the limit, I am not talking about the initial station. If that station fails, that station elements will transfer that overstressed, or we can say stress to the next, or we can say load to the next nearby station. So the load on that nearby station will increase because it has its own load and the load which is shifted by the faulty part. So that is called the overstress. And generator shuts down due to any reason, because if generator if any fault occurs on in the generator, and if it shuts down, and if it is connected to the interconnected power system, then that load, the load which still remains in the system, and that can be withstood by the other systems which are connected with the interconnected power system. So that's why cascade tripping can occur. And line has too much current flowing on it, means this is again, we can say it is a type of overstress, and it will be heated up and conductor fails. As the current limit will increase, the limit of the, we can say, the material which we use for the conductor, then overheating will occur. And due to overheating, suppose breakdown of the conductor can also occur. So the the line has too much current flowing on it, so as current increases, that conductor will get heated up. And if it remains for a particular time, then conductor might get fails, or it may get breakdown. And when tree is close to transmission line, and electric current from the line produces arc, means in the tree moisture is present, and if tree is very near to the transmission line, then ionization will occur between tree and conductor. And that the current which is transferring through the transmission line can be discharged through the tree in form of arc, and circuit breaker disconnects the line. So due to this causes, the cascade tripping can occur. The type of blackout, generally localized blackout, means a particular small area or zone, and full system blackout, or a particular district, means a particular means suppose I'm talking about Ahmedabad. In Ahmedabad we have lots of areas like Naranpura, and then Odhav, then Naroda. So Naroda is local blackout. Then full system blackout means whole Ahmedabad blackout. And the partial system blackout means the half portion of the Gujarat is blackout due to the cascade tripping. That is, these are the types of blackout. Now, before we study the cascade tripping, these are the sequence of blackout. So first of all, initial event means it is the starting stage of the blackout. So first of all, any events occur, like I explained the causes of cascade tripping, that is over stress, over current, heated of the conductor. So this is the initial event. Now due to that initial event, system will get separation, so system separation. And then that system is separated from the interconnected power system, so it is called the formation of island, because that is isolated from the grid. Now load or generation imbalance in the island, because as the system is get faulty and load demand is still there, then load means whatever the, suppose in that's suppose one station having 4 units, means 4 generators, and among that one generator fails and that system is isolated, then that 3 generators will drive that load. And so that's why the load demand and generation demand will change, because in previous condition it was that 4 units were connected to the to the grid, and the demand means extra demand will be means transferred by the other generating stations which were connected to the that area. Sorry. So now it is islanded, so the all the generating stations which are connected, uh, apart the full T generator, that three generator has to withstand that load, so imbalances occur, and due to that blackout of island will occur. And if blackout is occur, we need to restore that system. So after that islanding, we can restoration we can start the restoration process. So these are the common sequence or events of blackout. Now, causes of the blackout: if the cascade tripping occur in the consequent stations, so due to that the thermal overload occur, due to the thermal overload, cascade tripping can occur, because if the thermal overloads develop, and we can say overstressed are developed due to the transferring of subsequent stations, transferring of the load to the subsequent stations. And if they are unable to transfer the manage the load and demand, then sorry demand and generation, then cascade tripping can occur. Then the cascade tripping due to the voltage instabilities occur just because of the failure of the generator, or sudden load, sudden heavy load increase or decrease. Then cascade tripping due to the dynamic instability, means whenever system is in healthy condition, and continuously load is changing, means increasing or decreasing, so due to that dynamic instability will occur. Then cascade tripping due to the load or generation imbalance, means load is more and generation is less, then uh, that 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 will cause the cascade tripping, because that that load must be driven by the generating station, means local generating station. But that if that local generating station is unable to serve power to that load, then they will get overstressed, and that will transfer that load to the nearby station, and due to that the nearby station will get overstressed, and due to the cascade tripping will occur. Now, if the blackout occur due to the cascade tripping, then what are the adverse effect of blackout of the area on the society? So as we know that few hours or several days would have significant significant input impact on daily life, means entire economy can affected due to the blackout. And again, critical infrastructure such as communication, means if there is no electricity, then communication system will become fail. And transport be hampered, the heating and water supply, means water supply and other transportation also will be affected due to the power supply cut, because there is no communication, so we cannot transfer any things to the needy places. And supply would stop, and production process and trading would be ceased. So these are the very important sectors which really require the electricity. So if any cascade tripping, or means long tripping or long days power loss occur, then this might be get this problems can arise when the blackout occur. Then emergency services like fire, police and ambulance could not be called due to the breakdown of the telecommunication process, because there is no electricity, so no communication. This is the most major and important sector where the electricity or constant electrical supply is required. They have their own DG sets, but for long duration they cannot survive. So hospitals would only be able to work as long as the emergency power supply, means DG sets with fuel. So that will be costly for them, and financial trading and cash machine and supermarkets would in turn have to close down business. There is no electricity, so no means lights and other facilities in the malls and other areas, so which would ultimately causes a atmospheric catastrophic scenario, and due to this catastrophic scenario whole system will get disturbed due to the blackout. So this is the cascade tripping and blackout. Now if the cascade tripping occur, and if your system will become islanded, then we need to restore that system, and it is called the black start. So what is black start? Basically it is the restoration process of power station. Whenever the power station become islanded due to the overstressed situation, and as it is islanded, we need to restart that power station. So it is again it is also called a restoring process, or restarting process of the power station. So um, it is an operational without relying on external source. So if all generators are shut down, then power can be drawn from the grid. We can take that power to start the generator in the absence of grid, because if there is a blackout, then if grid is absent, then grid power, the black start must be needed to perform, because if there is no grid supply, so we require a DG set system or other external sources to start that unit. So to provide black start, some power station have some small diesel generators, and due to that diesel generator they can start the power if the generators are start developing the power, and if reaches up to the its rated value, then we can connect that generating station to the grid again. So it can be used to start the large generators for the several megawatts capacity, and also start the auxiliaries, like while generating units is restored is called the startup power. So that startup power can be provided with the help of diesel generator, and all the generating stations have the separate facilities. Some of small generating stations have suppose if they does not require, because they are connected with the grid, and they can maintain that generation and demand ratio with the help of grid, then they doesn't require such kind of generator in DG set system. But for large power stations, it requires such kind of auxiliary generators to restart, or for the black start of the unit. Now the requirement of the startup power by the various units are nuclear. It requires 7 to 10% of unit capacity. When suppose unit capacity is say 100 megawatt, then 7% of the unit capacity is required to start the nuclear thermal power station, and for hydro power station it is required 0.5 to 1% unit capacity, and for the gas power station it require 1.5 to 2% of the unit capacity. So you can see from this three, only hydropower station require the less unit capacity compared to the other generating station. So uh, from this we can say that hydroelectric stations needs very little initial power to start, and can put large block of power online, because it can drive the peak loads on the and hydropower stations are we can say very easy to restart, because it does not have more auxiliaries to start as nuclear and thermal power station. So it can be restarted very quickly, to allow startup of fossil fuel or nuclear stations. Means this can be, hydropower station can be useful to start the nuclear power station, thermal power station, or other power generating stations. So the certain types of gas power stations can be configured for black start, providing another option in place. So we can use gas power station also where the hydropower station facility is not available. So here we can give the example to facilitate the black start. Some of the power station have their own DG sets, like Ukai hydro power station has the capacity of 500 kVA DG available. Same Duaran thermal power station has 1000 kVA, means two set of DGs are available. For the Torrent Ahmedabad, 500 kVA is the capacity DG available, and Kakrapar nuclear power station has the 2250 kVA, 6 units of DGs are available for the black start. So these are the these are the mandatory, means requirement of any generating station to for the black start. Now this is the black start sequence. When the grid is not available, we need to black start the generating unit. So first of all, we will use the battery, and that battery supplies the small DG installed in the hydroelectric station, means for the field current. And this power is used to bring the hydroelectric generating stations to the operation. Means as field current is given, and if we rotate that generating station with the help of water, then that generating stations will start developing the power. That energies will transfer to the through the transmission lines between the hydro station and other areas, and that will start the coal fire based load plants. Means that power will transfer to the coal fire based power plant, because it requires large power initially to get start if it doesn't have the DG set requirement. And this process we can this system we can use for the black start, because it is cheaper compared to the DG set system. Now power from the base load plant will be useful to restart all other power plants in the system, including the nuclear power plants, means where the large power requirements are there for the restarting or restoring. And from the above process we can see that power is finally reapplied to the general electricity distribution network, and sent it to the consumers. So when such situation arise at that time, these are the common sequences which we use for the black start. And one more auxiliary is there, we can use our own DG at the premises, and we can restore the grid. So limitation of the black start resources. Generally it is not at all generating plants are suitable for black start capability. Means this facility is um, may be available or not be available for the all the generating plants. So uh, uh, wind power stations are not suitable for the black start, because throughout the day wind flow or wind pressure is uneven, so we cannot rely on the wind power station. So wind may not be available when it needed, maybe it available, or maybe it is not available, so it is not useful for the black start. So wind turbines and mini hydro or micro hydro plants are often connected to the induction generators, and which are incapable of providing power to the re-energize the network. Because if wind pressure is not available, then that induction generator or induction, as we know that induction motor runs at the negative sleep, then it will behave like a generator. So for that we need to rotate that the turbine at the negative sleep, or with, we can say, heavy speed. If wind speed is not available, then that will be not useful to restore the grid. Now after this presentation, you have the assignment question. So note down this assignment questions, and the important instruction related to the assignment question is written below the assignment question. The questions are: what do you mean by the cascade tripping and blackout? Also analyze the causes of both cascade tripping and blackout. And what do you mean by the black start? Explain the black start sequence with block diagram. Explain the effect of blackout in the society, and explain the limitation of the black start. So all the related instructions, please read it carefully, and submit the assignment as per schedule time. If you have any query, any doubt related to this topic, you can contact me. Feel free to call me, and we can solve your doubts and queries in our doubt solving session. Thank you very much, student. Jai Swaminarayan.